Welcome. It's always a joy for me to talk about symmetry and the art of MC Escher. I actually have had this presentation for several years, and I added something this year. I added 6 or 8 images of symmetry in nature. So you're getting the latest, greatest, most comprehensive presentation that I've ever given, and I'm very happy to be doing so. I want to congratulate all of you students for your success in round 1 of the competition, and I wish you well this afternoon when you take the test. I hope you all are winners. Do they all get, the winner gets what, $10,000 scholarship from PNM, is that right? How big is it? You know? Less than that. Okay. Well, I guess if you all were the winners, you might each get like $5 or $10 or something like that scholarship to UNM. Thank you. So I'll be walking around a little bit and just talking about the images, maybe pointing out some symmetry in the clothing of a few people. I don't see a whole lot from right here, but so if I do talk about the symmetry in your clothing, please don't feel embarrassed. It's just part of the show. Let's see, I need to press a button here. So, symmetry and the tessellation art of MC Escher. On the left, you see one of the most famous Escher designs called Day and Night. Most of the copies that he made of this, which were probably in the hundreds, were black and white, but there is one that he made that's blue and black, which is in this second panel back here. That is not an original, it's a poster. And the symmetry you see there is the idea that on the 2 sides of the creation are two things that look the same. It's just that on the left you have blackbirds against a white sky during the day, and you can see the town during daylight. And on the right-hand side, and a river reflecting the sunlight. And on the right-hand side, you see, white birds in a black sky with a dark river and a dark town. But they do seem to be similar, don't they? So they have what's called line symmetry. And on the right, you see a decoration from the Alhambra in Granada, Spain, which Escher happened to visit twice, and he was very inspired by the geometric designs he saw in the Alhambra. And in my travels, I wanted to go there, and I was able to go there one time when I was on an Intel trip to Israel. I stopped in Spain and got to see the many, many beautiful geometric designs in the Alhambra. On the left, you see, again, another one of Escher's famous designs called reptiles. I'm trying to remember if I have reptiles up here. I think it might be back there in the 3rd panel, the closest one to me, just to the right of those starfish and shells. This design, reptiles, he drew and then used watercolors to color. And that design is still in his notebook. But he used that design to create the lithograph, which is back there just to the left of, just to the right of the shells and starfish and so on. It's one of my favorite Escher designs. And then on the right is my favorite student design. For many years, I've taught students how to make tessellations, Escher-type tessellations. And I call this Cat's Eyes by Kana Aoki, who was a student from Hawaii I taught at University of the Pacific in 1982. So you see a bunch of cats peeking at you from behind the grass. Now, just a little bit to introduce the idea of symmetry. How many are you familiar with the idea of symmetry, you think? Okay, I'm sure you are, because there's so much symmetry in our world. So a design has a certain kind of symmetry if after you move the design in some way, the design looks the same after the motion as it did before the motion. So reflection symmetry, typical object that has reflection symmetry is an animal's body or a human body. We have 2 sides. There's a line of symmetry down the middle of us, And if we were able to fold ourselves completely, then every item on this side of my body, my right thumb, my right little finger and everything, my right shoulder, if I could put them together, they would match each other. And that's called mirror symmetry or fold or bilateral, meaning there's two sides separated by the line, also called line symmetry. Rotation symmetry or turn symmetry, one good example of that is the snakes poster in the first panel on your right. There are 3 snakes. If you looked at it more closely, you could see that those 3 snakes are identical in size and shape and color and scales and so on. And so if you were to rotate that image 120 degrees, a third of a circle, it would look the same as it does before you make that rotation. So that has what's called turn symmetry, and it's called threefold turn symmetry because there's 3 repetitions of the motif as you go around the circle. Translation symmetry, tessellations have a lot of translation symmetry. Translation symmetry simply means that the motif is moved to the right or to the left repeatedly or up and down or maybe at some angle. So when, like, as I look at this room here, I see essentially that what I see is a tessellation of chair backs. So you have this chair back can be translated to that one and then back to that one and back to that one. They can be translated back and forth, sort of east and west. Is that, no, it's actually north and south, and also east and west. So the image of all these chair backs has translation symmetry or glide symmetry. So you can think of something being translated as it's being glided, or maybe glud. Glid, I'm not sure what the past tense of glide is. It's probably glide. Then finally, there's something called glide reflection symmetry. I like to call it footstep symmetry, because if you imagine walking in the snow, the footsteps you make will be, each footstep, if you fold that pattern, they will match. But the thing is, they're offset a little bit. So in order for this footstep to match that footstep, I have to first glide it and then reflect it. And the reflection line is halfway between. Was there a question? I'm just hearing myself, I'm sorry.
Translation half a second.
Yeah, okay. Yeah, there's a time translation of my voice I get. So that's footstep symmetry. So these are the kinds of symmetries that you'll see in the images that I present. Does anybody have any questions? Okay, and you feel free to raise your hand or just shout out or something. I'm happy to take your questions as we go. So mirror symmetry, the line symmetry I already talked about. I don't think I need to go over the definition again. And here's 2 hands. That pattern has line symmetry. You can see the vertical line between, it's not there. You can't see the line, but you can imagine the vertical line between the 2 hands. Here, actually I have a pointer here. Let's see if I can use it. I find that these pointers shake a lot because I shake. So there's lines of symmetries down the middle of each of these sets of T's, okay? And so there's line symmetry with those vertical lines. And then there's also translation symmetry. You can translate this T to the right or up or at some angle. Parallel vertical lines there of symmetry. Lateral symmetry of most animals. And there's a famous poem by William Blake called, or what's the first line? Tiger, tiger burning bright, and then something about fearful symmetry at the end. Maybe it's a different adjective, I forget. And here's a human brain. Did I press something I shouldn't have with this? Okay, so the human brain, it's not perfectly symmetrical. You notice the folds on both sides of the vertical line are slightly different, but it looks symmetrical. And that's what we're really talking about here. We're not necessarily talking about perfect symmetry, but symmetry that may be suggested and not actually perfect symmetry. And here are a bunch of radiolarian skeletons, and you can see that there are lines of symmetry, like this central one. a vertical one, a horizontal one, and then there's also maybe not diagonal ones there. But there's lots of vertical lines of symmetry in all these skeletons and other lines of symmetry. For example, the top one here has vertical, horizontal, and these 45-degree angle lines of symmetry as well. And it has, rotational symmetry.
I don't know what a radiolarian is.
A radiolarian is a small sea creature that that has a skeleton, and when they die and they're dried out, that's what their skeletons look like. Yeah, I don't know a whole lot about them, but I certainly like the symmetry in their skeletons. Okay, and I have a feeling that a lot of the sediment that turns into sedimentary rock has skeletons of radiolarian and other, of course, other sea creatures. So here's some glide symmetry. These three girls with their dolls. If you just imagine gliding the pattern back and forth, the pattern will look the same after each glide. And this also has glide symmetry. You can imagine, let me go back here. Where was I? Yeah, you can imagine, for example, the center of this star with a flower in the middle gliding up there, or gliding down there, or gliding straight up and down, or gliding straight across. Notice, however, in this example, when you glide one of these 6-pointed stars up to the next one, what angle would that be? Whatever angle it is, it changes color. So some designs have just the shapes have the symmetries we're talking about, but also there's a change of color. And so one could say that this glide from here to here doesn't have perfect symmetry because the colors change, so it doesn't look the same quite. So one can ignore the colors and just think of the shapes having certain kinds of symmetries, or if you include the color, then some of those symmetries disappear or are disqualified because the color changes. This has mirror symmetry, vertical lines of symmetry down the center of each of these rows of sort of floral patterns. And it has glide symmetry, as you can see. Each one of those little flower-shaped objects can glide to any of the other ones. And if the whole pattern follows along, it'll look the same. Of course, one of the problems with glide symmetry is, if I glided that thing 2 or 3 motifs off to the right, it'd no longer be on the screen. You wouldn't see it anymore. So you have to imagine that the pattern goes on forever in order to really say, oh yeah, it's not going to change if you glide it. Rotation symmetry I talked about here. We have objects, little pinwheels that have 4-fold rotational symmetry. You can see that because it has 4 little wings to each pinwheel. This is a lovely 3-fold symmetrical Islamic dish with apparently peacocks. And a 4-fold rotational symmetry dish, also Islamic. And I want to have you notice that it also has line symmetry, vertical, horizontal lines, and also the 45-degree lines are lines of symmetry. Now, there's a couple parts of this design which are not just 4-fold rotational symmetry. If you count how many of these little objects there are, this is called a frieze pattern around a circle. You could have straight frieze patterns along a line or around a circle. That has something like 48 little repetitions of the same motif. So part of this plate or bowl has 48-fold rotational symmetry, approximately. You can't see them all, so I'm guessing. This is an unbelievable book by Scott Kim. It has symmetric calligraphy. So notice the word inversions at the top. If you were to stand on your head, this name, Scott Kim, of the author, would also be the word, you'd see inversions there, and you'd see Scott Kim up here. It's easier to see if you look to the right and the left. So here we have the word inversions to the right, and Scott Kim to the left if you turn your head this way. But if you turn your head the other way, Scott Kim on the left becomes inversions, and inversions on the right becomes Scott Kim. Scott Kim is an amazing individual. I invited him to my class at University of the Pacific, and he came, spoke about his symmetric calligraphy. And I had about 15 students, I think, in the class, and he invited each of them to come up and give him their names. And then he was able to, just in a minute or two, do a symmetric rendition of their name. Unbelievable. There were 2 or 3 who he couldn't do right away, and he said, well, I'll send them to you later. And he sent them in the mail, you know, a week later or so. So he's just an unbelievable individual. By the way, that book is over on my table here. I have a bunch of books there, and I have a bibliography there if anybody wants to pick up a copy of the bibliography. And also on that bibliography, there's an invitation to teachers if you want to talk to me about arranging a presentation at your school. I'm happy to do that. How many fold symmetry, rotational symmetry does this have? It's 5-fold, yeah, 5-fold. So if you count these little spirals, there's 1, 2, 3, 4, and 5 spirals. So that aloe has a 5-fold rotational symmetry. This is a Buckmaster fullerene molecule. It's not a real Buckmaster fullerene molecule. It's a model of a Buckmaster fullerene molecule. And it has 5-fold rotational symmetry. You can see partly from the pentagons, the one in front and the one in back. If you rotate that 1/5 of a circle, which is, what is 1/5 of 360 degrees? 72 degrees, yeah. It has 72 degree rotational symmetry, or 5-fold rotational symmetry. What other symmetries does it have? It has a line of symmetry here, going down the middle of this pentagon, and then this outer pentagon, and then each of the other, like vertex to opposite side of that front pentagon, will define a line of symmetry. So there's a bunch of lines of symmetry for this design as well. Starfish, 5-fold. This is an Islamic design with 6-fold rotational symmetry. Does this have a line of symmetry? The thing is, the flowers seem to be curving slightly to the left, or what, counterclockwise. And so those curving in one direction, if you were to reflect it in a line, it would curve the other direction. So this has 6-fold rotational symmetry, but it does not have line symmetry. Okay, so if you have a design where something is sort of bending in one direction, but not the other, then it may have rotational symmetry, but probably not line symmetry or mirror symmetry. Famous, famous, famous 6-fold rotational symmetry. How many of you have a book of snowflakes? I have 2 books of snowflakes. One of them is on the table. You can look at snowflakes over there. This is a butter mold, Pennsylvania, and it has 10-fold rotational symmetry. And you can see the curving of the little, I don't know what you'd call it, sort of like a mushroom shape. The curvings of the mushroom shapes counterclockwise prevent it from having line symmetry. Okay, this is that original, the thing that was in the second or third slide, a beautiful design from the Alhambra. And there are 12 of these little spokes in the design. So this central part at least has 12-fold rotational symmetry. Same is true of this star. It's a 12-pointed star, and the star defined by these little spikes is 12-fold. Notice, however, that these guys are facing opposite directions. This one's facing clockwise. It's pointing clockwise. This one is pointing counterclockwise. And so those little motifs don't participate in the 12-fold rotational symmetry. And then another part, these dark bands on the outside, of course, there's only 4 of those. So perhaps fourfold rotational symmetry just for that part of the design. So you'll find this in a lot of symmetric designs, that some parts of it will have one kind of symmetry but not another, and then some other part will have a different kind of symmetry. So they get a little mixed up, but it makes it very interesting. I find this very attractive. And of course, there are also lines of symmetry for parts of the design. This vertical line, if you fold the design on this vertical line, it'll match. Even these four dark bands will match when you fold down the center of the design. This is the dome of a mosque. Beautiful 16-fold rotational symmetry, and possibly also fold symmetry. It's a little subtle though, because you'll see that this little part here seems to go on top of this one. And so if you were to reflect, I believe that when this part is reflected to the other side, it will change which part, which of those two things is on top. A lovely little tile design with fourfold rotational and also lines of symmetry, vertical, horizontal, and at 45 degrees. Sometimes we call a design that has rotational symmetry and then also line symmetry, we call it kaleidoscopic. And for obvious reasons, if you look in a kaleidoscope, you see patterns that have that. The pattern will have rotational symmetry and also lines of symmetry. This, I found this when I was looking for patterns in nature. It's not so much the ball, although the ball does have some symmetry. It's all this, the sprays, the spiral sprays. And I didn't try to count how many separate little spray elements there are. I don't know, maybe 30, 40, 50 fold rotational symmetry. Glide reflection or footstep symmetry, I talked about briefly, but here's an example. I saw lots of examples of footsteps in the snow where the footprints were made with boots or shoes, but I found this one rather surprising. I probably wouldn't do that, at least not on a real cold day, walk barefoot. But I think you can see what footstep or glide reflection symmetry would be. The idea is, once again, if you glide this footstep up, then it'll completely match this footstep. And if you had a folding line between the two, after that glide, the two footsteps would match. And so it's a glide reflection, or I like to call it footstep. This is the same pattern we saw before. This also has glide reflection symmetry, because if I glide this T up to the level of this T and then fold it over, and the line of fold would be sort of halfway between the T's. So there's a line of symmetry in the middle of the T's, but there's a line of glide reflection or footstep symmetry between the T's. And once again, if you're looking for footstep symmetry, if you think of left, right, as you progress in one direction, you'll see that perhaps you'll see the footstep symmetry. So this is left, right, etc. And the line halfway between those footsteps is the line of glide reflection symmetry. This is a lovely Italian or Spanish, we don't know which, fabric from the 16th century. So we're in the 21st century. So this is like 500 years old. And you can see the forward and backward S's. That clues you that it's footstep symmetry. And then also, of course, there's glide symmetry here, glide symmetry from here up to here, glide symmetry from this S up to this S, and the whole pattern would follow those glides. And then there's also, does anybody see any rotational symmetry here? Where would be the centers of rotational symmetry? Yeah, in the middle of the S's right here. So if you rotate this S 180 degrees about this point, not only will this S turn in the other direction, but all the other S's, if the whole pattern is turned 180 degrees, the whole pattern will look the same. So this has twofold or 180-degree rotation symmetry centered at any one of the S's, at the center of the S's. Okay, let's see. Now I want to show you a few symmetric Islamic designs, although I've already done so, but I just want to focus here for a moment. This is a famous room in the Metropolitan Museum of Art. I'm not sure I necessarily condone this sort of thing, but this room was taken out of Syria, Damascus, and then put in the Metropolitan Museum of Art, probably a century ago or something. And you can see lots of different symmetric designs here. One that I don't have a detail of is the window up here. And I'm sorry you can't see it in more detail, but I do have a detail of this fountain looking thing, and I have a detail of one of these panels here in the next couple of slides. So there's the fountain viewed from the top. What kind of symmetries do you see? Rotational symmetry of how many copies? Yeah, it's 8-fold rotational symmetry. 360 divided by 8 is something like 45. Is that right? You know, when I'm standing in front of a crowd, my arithmetic skills kind of decline a little bit. But yeah, so 45-degree rotational symmetry or 8-fold rotational symmetry. And all the colors stay the same when you do those rotations. Now notice this one though, it's not quite 8-fold rotational symmetry. There are 8 little petals here, but they may not be exactly the same. I wouldn't bet on it. But there's also line symmetry. There's a vertical line, a horizontal line, and then lines through any pair of opposite sides, and then also lines through these vertices, opposite vertices. The lines connecting opposite vertices are lines of symmetry. However, there's not 8 copies of this little thing or this little thing. And so the whole pattern may not have 8-fold rotational symmetry, but parts of it do, obviously. And then here's one of the panels that were along the front edge of that step in the earlier picture. This is typical of one of the fundamental aspects of Islamic design, namely geometric. So in Islamic design, you have geometric aspects, you have calligraphic, in other words, calligraphy, and you also have vegetal, or vines and flowers and that sort of thing. I'm not Islamic, but my understanding is that there were prohibitions against depicting animals and humans and so on in Islamic design. And so you don't find that very often. So here we have 4-fold rotational symmetry. We have line symmetry. We also have footstep symmetry, like this one and this one and this one and so on. So left, right, also left, right. So there's glide reflection symmetry also. And of course, just regular glide symmetry. Lots of different kinds of symmetry in this design. Here's another geometric design that has calligraphy in it, as well as vegetal aspects. So this is a beautiful, I think, a beautiful synthesis of those 3 aspects of Islamic design: geometric, vegetal, and calligraphic. This is a picture that absolutely stuns me every time I see it. So this is a wall in Isfahan, Iran. A lot of people say they would rather not visit Iran. I would love to go visit and see this thing with my own eyes. And you can see the magnitude of it by looking at this man down here. So this is just massive. And you see geometric shapes down here, for example. You see calligraphy in the dark blue panels, and you see a lot of vegetal, floral sorts of shapes as well. Yeah, question.
Are those tiles or is it painted?
Those are tiles. Those are tiles, yeah. And here's a beautiful dome of the Imam Mosque in Isfahan, Iran, same city. I'd like to see this in person and feel safe doing so. Here you also see the geometric Well, it's not so much geometric, but there's lots of vegetal patterns. There's calligraphy here. And there is some geometric, like this arch here is sort of a geometric shape. And there's lots of glide symmetry. Although as you glide a pattern around a circle, it's really rotational. So glide and rotational symmetry are similar. There's a symmetry between glide symmetry and rotational symmetry. So if you have a glide symmetry on a circular sort of surface, as you glide around the surface, you get similarity or the same motif. You could call that rotational symmetry also. Okay, let's see. This is the inside of a mosque. And as I say in my little comment to the left, if I were sitting in there for a while, I would just feel very peaceful because of the changing light coming through those patterned windows and the beautiful geometry and symmetry of the designs. This is not to say that Christian churches also don't have beautiful interiors and exteriors. It's just I like to focus on the Islamic in my presentation. This is an African bead pattern that has vertical lines of symmetry through the red, through the black and white. There's glide symmetry. And I'm not sure there's rotational. Yeah, there's got to be rotational symmetry. If you rotate the whole pattern around this point in the middle of this diamond, it will turn upside down, but it'll look the same. It's just that this white will become this red, and this black will become this white. Actually, this black will become the white one over here, I think, if you rotate around that center. Sorry, this center, yeah. So it has, and then also you could say it has glide reflection, left, right, and so on. So this has all the kinds of symmetry, rotation, glide, and glide reflection. Here's the first slide mentioning Escher. This is a woodcut that he did when he was about 25 years old. He was born in 1898. And so in 1923, when he made this, he was about 25 years old. Now there's a certain amount of symmetry here. It's a human face after all, but you can see the curls of his hair and so on. There's a little bit difference in the left and right side of his head. This is a picture from the outside of the Alhambra Palace in Granada, Spain, where he visited twice. And as I said earlier, he was very impressed and very stimulated, and his entire life of productivity after visiting the Alhambra were influenced by the geometric designs he saw in the Alhambra. Here are some of those geometric designs in what's called the bathroom, the royal baths in the Alhambra. You can see several different symmetric designs there. And he, in his sketchbook, he sketched a lot of those designs, and then he used them to stimulate his further creativity later in life. So this is proof that he was inspired by these designs, as he took quite a bit of time and pain and effort to reproduce them in his sketchbook. I'm not going to read these. I'm just going to skip over these. These are some things that Escher said about his work. So now it's starting to get warm in here. Now's the time for me to take off a couple pieces of clothing. This design, as I told you, is a Celtic design, but underneath it, if I can do this, I may not be able to. Give me a moment. I have to get this out and take this shirt off and show you my second layer, if I can. I don't know if this is going to work. Could someone please take my microphone and then put it back? You know how to do that, you guys? Thank you.
It may be caught on your belt.
My Celtic design from of MC Escher that's called 8 Heads. Now, some of you may not, go ahead and put it back on my tongue. 4 heads. I mean, there's copies of each of the heads. So, I mean, 4 designs. So, yeah. So how many of you don't see anything at all? Because I don't see any hands. Maybe you're just counting. All right, so there's the man in the top hat. Next to him, there's the man with a little more grotesque face. And then there's this woman and this woman. So there's 4 heads there. And I've got that pattern on the back of this t-shirt. This is the first major tessellation work that Escher did. And you can see the other 4 heads if you look at the pattern upside down, which this is. So now you see this woman and this woman, or maybe it's a man, and you see this grotesque guy and this grotesque guy. So there are actually 8 heads that get repeated in this pattern. Now I want to tell a little story. So Escher has wondered through his life, he has wondered, how did I get so stimulated by tessellations, by these repeating patterns, by fitting little pieces together so they fit perfectly? And one day he was on a bus in the Netherlands, and this woman came up to him. I think he was like 40 or 50 years old. And the woman said, Mauk Escher, Mauk was his nickname. Is it you? And he said, yes, and they chatted. She said, do you remember when we were in grade school together? You would take your piece of bread and your cheese, and you would take the pieces of cheese and just cover the piece of bread with, with pieces of cheese that fit closely together. So that was his, maybe deep in his childhood, he became attached to the idea of tessellating. So that's that story. 8 heads, first tessellation. This is called Pegasus. You can see the glide symmetries, no other kind of symmetry here. And of course the color changes. This is called Boats and Fish. Again, only glide symmetries. This is one of my favorite ones, I think, mostly because of the nice colors and the beautiful shading and so on. And these colored pictures were all in his notebooks. This was not brought to the public to sell because he only had 1 sketch of this in his notebook. But then he created things like prints and so on that had these designs, these color designs from his notebook. These are horses and riders. And you see left, right, left, right, left, right. So here's a guy going to the left, and then another one going to the right, and then left and right. So what kind of symmetry does this have? Glide reflection or footstep. Say footstep meaning glide reflection. So there's footstep symmetry here, and then there's also obviously glide symmetry. You can glide the horses back and forth, up and down at angles and so on. So this is a tessellation. The idea of a tessellation is you have separate pieces that fit together without any overlaps or gaps. That was Escher's definition, and I think he was the one who invented the word tessellation. It comes from a Roman word, tessella, which means the little square stones that were used in mosaics. And then originally that came from a Greek word tessera, T-E-S-S-E-R-A, which I think meant 4. Because a lot of the pieces in mosaics way back then were squares. Here's another tessellation that has birds and fish, and you can see the left, right, and the glide symmetries and the glide reflection or footstep symmetry. Again, here you've got left, right. Here's a left one, here's a right one, here's a left one, here's a right one, and so on. So this has glide symmetries and glide reflection or footstep symmetries. This is an interesting one because it has twofold rotational symmetry where these heads of the butterflies meet and where the heads of the birds meet and where the heads of the bats meet. There's twofold symmetry, rotational symmetry at those places where those similar parts meet. And then of course there's also line symmetry. This line, down the middle of the creatures. So I don't know why that happens, but hopefully it'll go away. This is a very famous one called Sky and Water. I think I may have a copy of it if you want to look at it more closely. Yeah, back there. This one sold a lot of copies. So he's getting into what he called metamorphosis, where you have one set of patterns here, and as you move through the design, they metamorphose into other objects. So down below you have white fish and black water, and above they metamorphose into, the black water metamorphoses into black birds against a white sky. Okay, and here's the day and night one again, which I discussed earlier. Here's the reptiles one. In this case, of course, we had glide symmetry. The white reptile can glide up here, can glide here. So there's glide symmetry, but there's also threefold rotational symmetry where these right knees meet. So this is the right knee of the white guy, the right knee of the green guy, and the right knee of the brown guy. And there's also threefold rotational symmetry where the left cheeks meet. Okay, so hidden in these beautiful designs, sometimes there are symmetries that you don't notice right away. And this, by the way, this same design of reptiles is the one that I mentioned earlier. He used later in this lithograph. So this picture here in his notebook is exactly the picture that was on the previous slide, but he incorporated into design with a lot more stuff. I think he tells the story about how these reptiles are so bored in their two-dimensional, prison, but then one of them breaks free and becomes three-dimensional and climbs up to the highest point he can reach and snorts a snort of triumph, but then meekly disappears back into the two-dimensional prison. I think he told his story something like that. I love this particular piece. The four fish, fourfold rotational symmetry, where the four fins meet, back fins. There's one thing about these tessellation symmetries is when you have a certain kind of symmetry, like fourfold symmetry, typically there will be a kind of symmetry for every factor of that number. So the factors of 4 are 2. And there's twofold symmetry, for example, where these kind of chins meet here. And I think there's another one, but I'm not going to try to find it now. Interesting story about this. This was printed, this was in his notebook, but he printed it on silk. And before I visited Israel, I looked in the book of his work, and it said that this was in the Israeli Museum in Jerusalem. So I went to the Israeli Museum in Jerusalem. I told him I was coming. I said, I want to see the silk print of this design. And they said, oh, we don't have that. And then I showed them in the book. Oh, yes, you do, because it says right here. Of course, books can lie, I suppose. But then they looked further and looked further. They found it and brought it out. So I got to see the actual piece of silk that he printed this on. I'm not going to go into the details on this because I'm getting close to the end. I'll just show you some more pictures here of Escher's. Fourfold rotational symmetry where the noses meet here. Fourfold where these, what is this, the right elbow? And perhaps some other ones. But there's no line symmetry here because of the curving. Sun and moon, a beautiful tessellation which is decorated. So if you look at the lighter part, it's the sun. And if you look at the darker part, you see the moon. Where's the moon? In here somewhere? Moon and stars. So there's a night sky and a day sky all combined into this. And it's the foreground background dichotomy in art. So he was a genius at having the background, be as important as the foreground, or they're both grounds, I guess. This is a famous tessellation of the non-Euclidean plane done by Professor Coxeter, who was a Canadian mathematician and geometer. And when Escher saw this, he was stimulated to do stuff like this. So I call this devils and angels, but maybe they're angels and bats. I don't know. And it's also, oh, it's over there. I think I have a copy of that hanging on the wall here somewhere. Yeah, right here. And he did 2 or 3 other of these kinds of tessellations of non-Euclidean planes. And here's the famous drawing hands that his son loves so much. There is, at least suggested, a 2-fold rotational symmetry at the center, because if you rotate it 180 degrees, this hand will come around to this hand. But it'll look a little different because this pen is on top of the hand, but here this pen is below the hand. So it's not quite perfect rotational symmetry, but it definitely has the idea of 180 degree rotational symmetry. And this was his last graphic design called Snakes. It has 3-fold rotational symmetry for obvious reasons, but not fold symmetry. There's no lines of symmetry here. Then I have some student designs I want to show you. Many of these are on the wall. So I taught students how to do Escher type designs. Now, they're not as good as Escher, most of them, but I think they're really beautiful. Cats and birds, doggies, birds. I love the coloring of this. By varying the coloring, you can get a really interesting effect. Penguins, it's not a whole lot you can do with the colors of penguins, I suppose. Birds, parrots, nice variation of colors. And this I really love. It's a design where she didn't color in all of the motifs. She just colored in a few and then suggested that it could be completed. But I think just stop, sometimes it's nice to know when to stop, which I'll do shortly. Here's the cat's eyes by Kana Aoki. This girl said that she was doing a proposal for a cosmetics ad. So some cosmetics company, if it had a lot of different colors, might be interested in using something like this to advertise their various cosmetics. Beautiful. This is a stained glass window, 4-fold rotational symmetry and line symmetry in all 4 directions, up, down, left, right, and at the angles. So this has kaleidoscopic symmetry. And this is too complicated to say a whole lot about, but it's just beautiful. There's 6-fold rotational symmetry here, and I think somewhere else. And now the secrets behind it all, I say, and these designs are, there's 2 of them back there on the last panel of the next 3 designs. It shows at the bottom just how to create this design. Namely, you take a square and take a bite out of it, and then paste the bite to the other side, and you construct some protrudence on one side, and then take a bite out of the opposite side of that same shape. Then those tiles will fit together, just like the square tiles on the floor outside or these square tiles in the ceiling. It's just that they have a different shape now. And if you colored them nicely, it's very pleasing. And then this is one where, because regular hexagons also have equal or congruent opposite sides, you can modify the opposite sides of a regular hexagon and create an interesting pattern, as she did here. And finally, this one has some rotation. So to get a design that has rotational symmetry, this has 6-fold rotational symmetry here. You take one side of an equilateral triangle, you modify it, but then you kind of nail it down at the top and let it swing over to the other side. And when you fit these together, a whole bunch of these pieces that you get, they form this hexagonal shape with 6-fold rotational symmetry. Thank you, and I'm open for questions for a few minutes if you have them. Oh, thank you. I didn't get to take off my other t-shirts, but oh well. But you see my other tie now. Question? Fractals, yes. Fractals obviously have beautiful symmetric patterns. It's just not something that I addressed in this presentation. I don't actually have a lot of information about fractals, although I have studied them some. How many of you are familiar with fractal designs? Have you ever been to the first Friday Fractals presentation at the museum downtown? Very interesting. That man is a genius. So yeah, fractals are wonderful and fascinating and beautiful. It's just I haven't addressed them here. Any other questions or comments or concerns or hungers, or I didn't bring any cookies. Yeah.
Are the Islamic artists trying to do something with their symmetry besides just making it?
The question is, so were the Islamic artists or craftsmen trying to do something other than just create a symmetric design? I can't really speak to that. I could guess, I suppose. But remember, again, they were apparently prohibited from creating images of humans and animals. And so, you know, where was their creativity to go? Geometry, plant designs, vegetal designs, and of course, calligraphy, say from the Quran. So they were, you know, in my view, they were very stimulated to do things that they were not prohibited from doing. And they did it very, very well. And I find it very fascinating. I'm not sure that answers your question, but I don't know what was in their minds, except they wanted to be creative in some way. A lot of it has to do with decorating their mosques and other buildings. So, other questions? Yeah.
I've heard conflicting reports as to whether every single additional 150 factors
Yeah, that's an interesting question. The question is, do all the, and by the way, there are 17 possible types of symmetry designs. Of course, you get different animals and different, you know, other motifs. But if you look just at the symmetries, there are 17 different combinations of symmetries that can happen in a tessellation. And his question is, do all of those types of symmetry combinations occur in the Alhambra? Now, some people say yes, but there's a man, Branko Grunbaum, who was a professor at the University of Washington. I think I have his book here. It's called Tilings and Patterns, something like that. Who I believe says no. I think he found a symmetry group or two, which at least in his view, they don't appear in the Alhambra. So I personally can't vouch for one view or the other. Most of them do appear, most of them, but maybe there's one or two that don't. And I didn't read up Grunbaum's paper before coming here today, so I'm not sure why he says that. I want to invite you, those of you who are interested, to come up and take a look at some of the books I have. I have a half-sheet bibliography over there, at the bottom of which says if you're a teacher and you think your school might want a presentation, something like this. Or when I taught at Rio Rancho High School, I did a symmetry festival where I taught the students about symmetry and taught them about making tessellations. And then they had a tessellation contest, and I gave shirts and other prizes to the top 3 designs. I'm not sure I have enough to do that for all your schools, but I would be happy to come to your school and further spread the joy of symmetry and the tessellation art of MC Escher. Is there one last question or two? Go ahead.
Our online audience. So this is from Iris87. She asks, how do you draw a symmetric picture?
A symmetric picture. If you, I don't know if your camera can focus on those 3 last drawings on that side of the room, and then, oh yeah, if I go back in my presentation to those designs, yeah, good idea. So this is the simplest type for the audience member calling in. So what you do is you alter one side of a square, but in this case, you take a bite out of it, and then you paste that to the opposite side of the square. And similarly, make an alteration to the left side of the square and make a similar alteration to the right side of the square. This is a protuberance, and so you have to have an indentation on the left. So here I have a spike reaching out and a insert into which other spikes from similar tiles could fit. And then similarly on top and bottom, another shape like this with this spike can nestle into this little indentation for the bottom of the tile. And you can see in the design that like this orange one nestles into the white one, which nestles into the next orange one, and so on. And this black one, or whatever color it is, nestles into the white one next to it, which nestles into this black, into this white, into this orange, into this white. So once you do the alteration of the opposite sides of a square, you could do this with a rectangle also, or a hexagon. If you alter the opposite sides in the same way, you get a tile which will fit together, you know, over and over and over again. So I hope that answers the question.
Thank you.
Is there another question?
I wonder if you mapping the pattern, let's say, to music, we would have like rhythms that kind of mapping, you know, different concepts of this.
You're asking about music?
Yeah, I'm just wondering, do you have like similar concepts?
Yeah, you do have similar concepts in music. How many of you are musicians? Probably quite a few of you, yeah. And I'm a singer. And so glide symmetry in music would sound like da 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 da. I don't know whose tune that is, but the repetition of the pattern is like a glide symmetry if you look at the notes on the sheet of music. And then line symmetry or reflection symmetry would be da 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 da. So in the middle of each of those peaks, there would be a line of symmetry to the notes on the sheet of music. I'm not sure about glide reflection. I haven't tried that one. Question. Like a glissando? I've heard of glissando, but I don't know for sure. Check it out. Look at the piece of music on your music sheet and see if there's glide reflection or footstep type symmetry in that piece of music. I'll have to check that out myself. Maybe I'll write a song that has glide reflection. Yeah.
How about rotational symmetry in a rondo?
In a rondo? Yeah, a rondo in music, I think more of glide symmetry, because you're like Frère Jacques, Frère Jacques. So it's a glide. It's more like a glide symmetry, but I don't know if it comes around again. It just keeps repeating itself, sort of. But then if you have two different voices, da da da, and somebody else goes in da 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 da, and there's a there's repetition that's offset by each of the voices. I kind of think of that as glide, but I could be convinced otherwise. Other questions? Yeah.
So I was kind of intrigued by the carbon molecule that kind of looked like a soccer ball, because if you looked at the pentagon, then it had 5-fold rotational symmetry, but if you looked at the hexagon, then it had 3-fold rotational symmetry. And that was kind of interesting to me, because 5 and 3 aren't what is it?
Primes.
Yeah.
Primes.
Yeah. I was wondering if that's only possible in 3D shapes, or if it's also possible in 3D shapes, if it's not without three-dimensional shapes.
Could you just repeat your bottom line question again?
Is it possible for that type of rotational symmetry, where if you look at it at one point, it has X-fold rotational symmetry, and if you look at another point, it has like Y-fold rotational symmetry, and X and Y are like multiples?
Are not multiples of each other? Yeah, well, in some of the designs I showed you, there was 4-fold rotational symmetry, but then there was also 2-fold rotational symmetry. Similarly, if you have a pattern that has a tessellation, which has 6-fold rotational symmetry, there will be points of 2-fold and of 3-fold, the two factors of 6. I don't know about three-dimensional, like crystallographic kinds of structures, whether that can happen in 3 dimensions, but I suspect that it does. There are books about crystallography that examine the symmetries of crystal structures. I suspect you would find something like that there, but I don't know personally for a fact. Last question? No? Yeah?
Well, I was just kind of, in response to Dave's question, in planar symmetry, you can't even have 5-fold symmetry, period. Perfect.
Not a tessellation. Yeah, it's been shown that if you have a tessellation made up of like pentagons, that it's not repeating. In other words, it can't repeat like the squares in the ceiling that can go on forever. But if you tessellate with pentagons, I believe, I don't know the exact theorem, but it has to do with, who is that physicist in England that did this? Penrose, yeah, Roger Penrose has a theorem about some impossibilities in terms of five-fold symmetries in tessellations, and I don't remember exactly what the theorem is. Do you?
Well, you can't tessellate with pentagons,
Right.
and you also can't have five-fold symmetry in a tessellation.
Yeah.
Two different differences.
Okay. Okay. You can tessellate with some pentagons, is it, but not perfectly regular, and there won't be five-fold rotational symmetry throughout the pattern. Yeah, something like that. It's like there's no closed form solution to all, what, 5-degree equations? Oh yeah. Okay. Well, thank you all very much. I enjoyed it, and I invite you to take a look at the books and chat with me if you want to come chat. And if you want to contact me about a presentation at your school, my information is up there.